At first, the concept up here might seem a little confusing, if not downright scary. It's limiting an excess of reagents, and all a reagent is a reagent is simply another word for a reactant. Reactant is a reagent, that is the same thing. So what I have here is a picture of my favorite virtual restaurant, Bistro Americano, or as the Italians who made the restaurant pronounce it, Bistro Americano. And this is a very weird Italian restaurant because they only sell steaks. And if you look at our economics videos, you'll see very quickly why this is a horrible restaurant and why it'll go out of business very quickly if they only sell one thing. So what Bistro Americano is doing is they're offering a special deal today. You get 2 steaks for every plate that you buy. 2 steaks in 1 plate. What an amazing deal. Actually, it might not be because the plates cost $10.99 a piece. However, that's for a later video. But we're just going to look right now at 2 steaks. So what we're going to see is 2 steaks. Write a chemical equation here. 2 steaks plus 1 plate is equal to 1 dish. And basically a dish is equal to 2 steaks and a plate. Now if I simply do this, and I erase this equal to sign, and I replace it with this arrow, we now see that we have a chemical formula. Although it's a real life chemical formula, not made up of elements, it is simply made up of steaks and plates. So let's say that I open Bistro Americano, and I take it over, and I have stocked up 500 steaks. Stocked up 500 steaks and 10 let's say 100 plates. Stacked up 500 steaks and I have 100 plates. Well, I want to know which is going to run out first. Which will run out? Which is going to run out first? Will I be expecting to have more steaks at the end? At the end of the day, am I going to have steaks left or am I going to have plates left? So, which one will run out first? Well, the one that runs out first, or simply put, limits the amount of reactant, of product that can be produced, these are called the limiting reactant. It's the limiting reactant. The other one is the excess reactant. Other one is the excess reactant. So if I look back at my 500 steaks and 100 plates, I want to find out which one's going to run out first. Well, here's what I'm going to do. I'm going to rewrite these here up at the top. 500 steaks and 100 plates. And I'm going to draw a partition down the center. And actually, I'm going to erase this partition partly because we need to keep the reactants at the top. But the reason I'm drawing this partition is because we have 2 different methods. Actually, there are lots of methods, possibly even hundreds of methods that we can use to find the limiting reactant. But in this video, I'm only going to talk about 2. So on this side, we're going to be doing the one with 1 calculation. On this side, it's going to be 1 calculation. On this side, you're going to need to perform 2 calculations. Let's start with the harder of the 2. This one here. So essentially, what you're doing here is you're taking if R1 is reactant 1, R2 is reactant 2, we're basically going to convert them to the products. So they're both, keep in mind that these are both the same products. The only thing that differs is the amount of product. So this is both going to be dishes, however the number of dishes is going to be different. What we do then is we compare them and we see if P1 is greater than, less than, or equal to P2. If it's greater than, then we know that reactant 2 is the one that we have to go with. It's counterintuitive. If P1 is greater, if this one's the greater one, then we know that it's reactant 2 that's the limiting. If P1 is less than P2, then we know that the reactant 1 is limiting. And if they're both equal, then we know we don't have a limiting reactant. So if we start here, to do this, we'd have to convert 500 steaks to dishes. So 500 steaks, and we're going to convert them and see how many dishes can we produce. So we know that if we have 500 steaks, and we convert 500 steaks, and we're able to convert it right to dishes. And we know back from our chemical formula that that 2 steaks are required to make 1 dish. So how many dishes can we make? Well, if we multiply this out and we cross out our steaks, then we know that we can produce 250 dishes. But if now we have to take 100 plates and convert them to dishes. And we take 100 plates and we multiply them by plates, and we know that takes 1 plate to make 1 dish. And when we cross these out and we multiply it, then we know that we have 100 dishes. Now, remember how I said it was counterintuitive? You have to look at the one that has less, not the one that produces more. So if we compare P1 to P2, we see that this one is greater, so then plates is the limiting reactant. See here that plates is limiting. Let's go ahead and go. This one, as I said before, requires more calculation. This one here, on the other hand, requires the other method, which I'm going to show you on this side here, requires significantly less calculation, because there's only one step to it. What we have to do is we have to just choose one. We choose one of them, R1 or R2, and after we choose one of them, then the next thing that we have to do is just convert that to the product, or to the second reactant, R1 to R2. And if we see that R2 is greater than, less than, or is less than, greater than, or equal to the R2 that's given, then we know that which reactant is limiting. So if we take 500 steaks and we say that 500 each steak needs 1 plate, 2 steaks per plate, we see that we need 250 plates. The problem is that 250 plates is less than the number that we're given, which is greater than 100 plates. Therefore, we don't have enough plates to sustain the number of steaks that we have. So we need more plates, therefore the plates are limiting. When we do this, please watch future videos, because these will include these elements. We use steaks and plates here, but in the future, we might have a reaction such as, let's say, carbon plus oxygen gives you carbon dioxide. We might be given 10 grams of carbon and 20 grams of oxygen and be told to find the limiting reactant. And we need to use these methods. Remember, you can think of carbon as stakes and oxygen as plates. So what these limiting reactants will do also is be sure to go check out our videos on moles and molar mass and ratios too, and then also our previous video of using conversion factors, because this conversion factor are going to be very important when you're trying to find the limiting reactant. There are a couple of things that you have to remember when finding the limiting reactant. Always find the limiting reactant. Now there are a couple of exceptions to this rule. One of them is in this reaction. Water decomposes into hydrogen and oxygen. This, you do not need to find the limiting reactant because there's only one reactant, that's the water. Also, if they only give you, if the equation looked like this, and they were to give you, for example, hydrogen, 1 gram of hydrogen reacts with excess oxygen. This with excess implies that you have excess oxygen. Then you don't need to find the limiting reactant. The last thing that we need to talk about before we leave is the concept of, let's just erase this board here, is the concept of reactant left behind after the reaction. This requires a little bit of knowledge of the theoretical and percent yield. Now, for example, let's say that in our reaction that we have oxygen, that we have found that oxygen is limiting because we have reacted one mole of it. We'll make it simple. We'll react 1 mole of it, and 1 mole and 6 moles of hydrogen. So we reacted 1 mole of oxygen and 6 moles of water. Therefore, oxygen is clearly limiting. So we need to find out the amount of excess reactant left over after the reaction. So what we need to do is we need to take whatever our limiting reactant is, and we need to find out how much of the excess reactant we were using. So we're going to convert 1 mole of oxygen into moles of hydrogen. Now here's the reason why. We need to we used up all of our oxygen. Once we did that, our water production stops. So we used up all of our oxygen, but there's still going to be some hydrogen left over because we didn't use all of it because it is the excess reactant. So how much hydrogen that's left is going to be the difference between how much hydrogen we started with and how much was used up. How much was used up is going to be however much is required to react completely with this oxygen. In other words, if we convert 1 mole of oxygen to the moles of hydrogen, we will get exactly the number of moles of hydrogen used to completely use up this oxygen. So if we convert 1 mole of oxygen and we take 1 mole of oxygen into moles of hydrogen, then we take 2 moles of hydrogen into 1 mole of oxygen, we cross these out, and we get 2 moles of hydrogen are used up. So now if we take the 6 moles of hydrogen that we started with, and we subtract the 2 moles of hydrogen that we used up in the reaction, then we will get 4 moles of hydrogen left. Essentially, we use up just enough excess reactant to completely use up the limiting reactant. So the amount that's left over is going to be however much we started with minus however much was required to completely use up the limiting reactant. This lesson is extremely important when dealing with theoretical and percent yield, which is our next video. Please refer back to this video if you have any questions about this concept. And if you still have questions about this, please remember to log into our chat sessions and into our discussion board.